Okay, hello. Good evening, everyone. Happy Friday. Hello, everyone. Ooh, more people today. Hi, Hoey, and hi, Sean. Hey, Sean, I haven't seen you in a while. How are you doing? Okay, guys. We are continuing with our revision today. So for those who didn't attend my previous class, please submit your request. I will send you the video last week, which is chapter 6. Okay, so should be around there lah. Right. Right. Anyway, just a moment. Okay. Yes, Ryan. Hello. Good evening. So we are in this chapter 7 revision today. Okay. So we are doing our chemistry revision today. Okay. Chapter 7. I hope I can cover 2 chapters today. Okay. So, let's go to chapter 7. Okay. Let's go to chapter 7. So this is our particle theory. Okay. Our particle theory. So, guys, today's lesson will be a bit sian, will be a bit boring, because this chapter memang is a bit boring one. Okay, so particle theory, that means 分子particle 就是分子Okay, so anyway, so matter is made from particle. I think this one you learn in year 6 also. Sorry, year 7 是吗？好像是year 7有学过so your particles, and then particles this is called 分子啦。Particles is 分子。And then particles are tiny and discrete. Discrete 的意思就是分开 they are very separated. That means particles, they are not like clay, not like 粘土they are not like you fuse and they together and they become one. No. Okay, they will stick and then they will divide. Okay, it's like Lego. You know Lego, right? Lego is like one piece, you put together 2 pieces and you take out one piece. Okay, 它不可以讲2个 Lego 合在一起变一个大力的 Lego，不是这样子的Okay, so please learn how to draw your solid, how to draw your liquid, how to draw your gas. Okay, very easy. And then and learn what happens here. Okay, solid, they are very close, liquid close, gas very far. Okay, I just highlight the main point. Close, very close, close, very far. Okay, and then space, very small. Okay, there's no space here. The space also affects the compressibility. Okay, 空间会影响压缩性，可不可以压？ Okay, how can you press this thing? So since this is very small, right? You see, I cannot press them anymore. It's like this room is already full. I cannot say, hey, you guys go in a bit. I want to put one more person here. No, you cannot because it's already full. And then this liquid, difficult to compress. I would say liquid is almost impossible to compress. Almost. Okay, and then gas, you see, a lot of space, so you can very easily compress them. Okay, 很容易你可以把它加在一起了。Okay, so anyway, and then you have your movement. Movement, how do they move? So they vibrate 咯。他们没有在动，他们只是 vibrate 罢了。This one they move freely, this one they move randomly. 这个是自由动，这个是乱乱动。自由跟乱乱，okay, freely and randomly. And then volume, fix, follow container, okay, not fix. Shape, fix, not fix, not fix. Okay, so volume is fixed for liquid and solid. If I have a ice cube, 100 ml ice cube, I cannot compress it to 99. If I have 100 ml water, I cannot compress the water to 99 also. Okay, you get the point lah. Anyway, guys, you don't need me to repeat this. Okay, you learn this in primary school. Okay, 小学学了的and you learn this in year 7, and then you learn this in year 8. Now year 9 you're learning it again. If you get this wrong, this one very malu one, please don't get this wrong. So please kindly cancel away this. Okay, take note of the arrow. Red means they are becoming hotter, they are becoming warmer, they absorb energy, they absorb heat. Cold, blue means they become colder, they release energy. Okay, they release energy. And then what is diffusion? Okay, diffusion is 渗透 diffusion. This one very easy. Diffusion is the spreading. Okay, spreading. Your mom sprays perfume. Your mom sprays perfume in a room, and then the perfume spreads out everywhere. Okay, and then you can smell the perfume. Okay, so Felice, have you learned this before? Felice, have you learned this before? Uh, you will learn this again in chemistry next time. Oh yes, okay, then good. Have you learned the solid, liquid, gas one? Okay, so to diffuse in solid, they are very slow. Okay, very slow because the space is very small. Okay, space is very small. Oops, here. Space very small. That means, right, if you want to diffuse into solid, right, you see, the space very hard to squeeze through. So very slow. Liquid, faster. Okay, because there's more space. Gas, very fast because they, have a lot of space. So you see, gas, they can spread out very easily. So 很容易在空气里面渗透。That's why your mom sprays perfume, or when your mom cooks in the kitchen, after a few seconds you can smell it because things diffuse in gas very quickly. So when you know this one, you know already lah. So anyway, gas pressure. What is gas pressure? When particles they hit the wall of container. Okay, imagine this is particle 这个是分子它打到 wall of container, they hit your wall, so they create pressure. Okay, so they create gas pressure. So there's two factors here. Okay, there's volume and temperature. This one very easy. Smaller the volume, higher the pressure. Okay, your room becomes smaller, you feel more pressure. Okay, and then higher the temperature, higher the pressure. Okay, when the room is hotter, you feel more pressure. Very easy to remember. Okay, guys, you will learn this in physics next time. So pay attention. What is atmospheric pressure? That's the pressure pressing on your head. Okay, pressing on your head. So I want you to pay attention here. Higher the altitude, lower the atmospheric pressure. That means if you're at a low ground, okay, there's a lot of air pressing on your head. So high pressure. Okay, if you're at mountain, very little air on your head. So low pressure. Easy to remember this. Okay, so I hope you understand this. You learn this in year 8 also. Okay, so let's go to the exercise. Okay. Okay, let's go to that. Hang on, let me reply a message first. Okay, so let's move on. Let's go to our exercise here. Sorry. Okay, so I have to reply a student real quick. So let me give you the answer lah. Straight away get to the answer lah. So for stone, this is a solid. So you draw your particles like this. Okay, make sure they are very arranged. Since this is a solid. Guys, try to draw your atoms big. You don't be so cute and try draw small. Draw die you, I tell you. 画死你我跟你讲。Please don't be like this. Please be smart. And then your liquid is like this. Okay, liquid is like this. So this is liquid. And then your gas, just verify. Gas. Okay, so state the arrangement of particles for stone and balloon. Okay, stone and balloon. So arrangement, how are they arranged? 他们怎样排? So for stone is very close. Okay, gas balloon is very far. Okay, so C, state the differences in the movement of particle between stone and balloon. Movement. How do they move? Stone, this one cannot move on, they just vibrate. Okay, they just vibrate. Vibrate at fixed position. Okay, so they just vibrate. Gas, they move randomly. Okay, remember, liquid is freely, gas is randomly. Gas is more crazy. Okay, 这个比较自由，动比较快。So D, explain why balloon is easier to compress. Easy lah, because there's a lot of space, right? Okay, 很多空间，所以你给它把它压在一起咯。So you have more space between particles. Okay, more space between particles. So E, explain why a stone has a definite shape. So why are they not flowing? Why is a stone a stone? Why are they not becoming a liquid? Because the atoms cannot move, the particles cannot move. Okay, particles cannot move freely. Okay, or they are at fixed position. All right. Just a curious question, guys. Any of you finish your exam already? Your final exam? 你们有人考完试了吗? Your final exam? If you do, right? Okay, if any of you do, right? Anyone? Because if you do, maybe in your December class maybe if you are still here for December, or maybe end of November, maybe I will teach a little bit of year 10 stuff for you. I mean, if you're interested because since you're learning year 10 stuff anyway next year, so why not we learn a little bit of more interesting stuff? Okay, any of you interested in biology? Okay, I'll let you taste a little bit how biology is like, how difficult it is. Okay, not very difficult, but it's more interesting lah. Okay, I can talk a little bit of chemistry, I can talk a little bit of physics, I can talk a little bit of chemistry. Okay, so depends on you. Okay, so if any one of you finish exam, you let me know. So F, explain why coffee can flow. Because particles can move freely. Okay, particles move freely, or not at fixed position. They just flow nicely. Okay, so next, classify the following substance into solid, liquid, gas. So your charcoal is a solid, steam gas, hydrogen gas, ice solid, petrol liquid, kerosene. What is kerosene? Kerosene is the same as petrol. Okay, liquid also. You find this in thinner, paint thinner, thinner 水 the one you found in your paint. And then this is your sulfur solid, mercury is liquid. Okay, mercury is the one you find in your thermometer. Okay, in your thermometer. Right? Okay, so number 2, matter has mass and occupies space. It consists of small particles. Shows an example of a matter. So state the matter of P and Q. P, I think, is pointing to the coffee. So P is a liquid. Q is a solid. So Q is the cup. So a spoon of coffee powder was poured into a cup of coffee. A cup of water, sorry. After 15 seconds, water changed to black color. How does the water turn black? Right, so this is diffusion. Okay, so this is diffusion. So you can say your coffee particles, diffuse in water. Okay, they diffuse in water. So they move in between the space of water molecules. Okay, water particles. That means if, okay, let's say this is water, right? Okay, this is water. This is water. When I make coffee, that means the coffee will move in between here. So now you have nice black cup of coffee lah. So this is when you stir, you make them go faster. So this is your okay diffusion. Okay, like I said lah, guys, very simple, straightforward stuff. That's why this is a bit boring. So particles of one of the matter. So this is your solid. So describe the arrangement and movement. Okay, we mentioned that up there already. Arrangement, they are arranged uniformly, okay, or at fixed position. Okay, movement, they are fixed. Okay, cannot move freely. I will accept also. Okay, so okay, that's the answer. Can say vibrate. Yeah, sure. Oh yeah, that's the vibrate. Sorry. Okay, nice one, Felice. Sorry, forgot to mention that. So vibrate. Yeah, sure. Very good. It's a very good answer. So moving on. Number three. Number three. So diagram 4 shows Jihan frying some chicken in the wok. So P and Q or P. Okay, guys, you see when you cook oil okay, did they say this is oil okay, frying is oil So when you fry oil, right, oil they produce vapor also There's water vapor, okay, 水蒸气, and then there's oil vapor, 油蒸气. Okay, so this is why when you cook, right, you have to switch on the exhaust fan so that you can draw the vapor out. If not, your house will be very oily. So this is gas, and the wok is solid. Okay, next, draw the arrangement of particles P and Q. So P is a gas, Q is a solid. Too easy lah. This is so easy. Okay, so relate the compressibility of P with its arrangement of particles. So what is the compressibility? That means can you compress them? Okay, so we can say P can be compressed because there are spaces. Okay, there are spaces between particles. Okay, there are spaces between particles, so they can just compress them further. So relate the shape and volume with arrangement. So Q, they have fixed shape and fixed volume. Fixed shape and volume. Okay, with this arrangement. Because the particles are arranged at fixed position. Or you can say cannot move. Same answer lah, over and over again. That's why, guys, I tell you this lah, next year, right, when you go, I don't know about you lah, I think chemistry and physics, they are the easiest. Not sure for girls though. Okay, so Felice, I'm sure you like biology more than chemistry and physics, right? Especially electricity. Especially electricity. Okay, but I don't know for boys, chemistry and physics will be the easy one for you. Biology will be the hard one because there's a lot of things to memorize. I don't know somehow girls they like memorizing stuff. Boys they like calculating stuff because boys you just find calculating stuff fun. 算东西很好玩. Okay, a lot of the ionic, so you don't like it, right? It's like Rubik's Cube lah. You see playing Rubik's Cube one is usually guys one. Right? Do you see girls playing Rubik's Cube? No. Because I don't know all these nerdy stuff all the 书呆子 stuff is mostly for guys one. Okay, ask me how I know lah. I'm an engineer. Okay, I studied physics all my life. So I'm sure you guys know this lah. When you talk about gaming PC, you talk about technology. You talk about drone. Okay, you talk about the latest phone. Okay, what chipset, what this and that, what graphic cards. Most girls will say, "What the hell? What difference does it make?" But for guys, wow. Okay, RTX 4090 lah. Okay, any of you gamer here? Any gamer here? What graphic cards are you using? Okay, anyway, if you understand what I'm trying to say here. Okay, so number 4. The diagram shows an activity carried out to study the diffusion of particles in gas. So this is air here. So they put bromine here. Okay, so bromine is brown color, by the way. Bromine is brown color. So this thing, when this thing is open, okay, when this thing you open, you will start to see this thing turn brown. Diffusion law. It's like your mom's perfume spread out in a room. So based on the diagram above, explain why the tube turned brown after a few minutes. Okay, this is because of diffusion. Okay, so the bromine particles move in between air particles. Okay, like I said, diffusion is about moving away, moving into. It's like you have a gang of blue shirt people. Now we are a gang of white red shirt people. We have to walk in between them. So when red and blue they mix, like shuffling lah. When they shuffle, it's like you shuffle your card. When you shuffle together, that is diffusion. Okay, so here very easy to shuffle because a lot of space. So diffusion lah. Okay, so this is your bromine gas particle. Explain the movement of the bromine gas particle. Okay, they just want to ask you how gas moves lah. So they move randomly. Okay, they move randomly, and sometimes they collide with each other. They collide 就是撞, so they move and they collide. That's how I create air pressure. Okay, air pressure. So give the definition of diffusion. Diffusion is the spreading. Okay, spreading of particles of a substance into another substance. It's spread into another substance. Okay, so next, shall we move on? So this is another diffusion question. Okay, another diffusion. This is diffusion lah. When you see, some food colorings are dropped into a container contains gelatin. Guys, you know it's gelatin. You know it's gelatin. You know jello. You know gelatin. You make your kueh with this thing gelatin or jello lah. You know, you call it jello lah. So if you want to make your oh, why is this so disgusting? Jello lah. This is with color lah, of course. You know, dan choi go. You go eat dan choi go. Dan choi go is like that one. So, okay, so gelatin, right? Okay, so when you put coloring into this, so it will spread out in the gelatin. So, explain why there are various colors spread in the gelatin after a while. So, this is diffusion lah. Again, same explanation. This is diffusion. Diffusion of what? Diffusion of the particles. Okay, particles of food coloring. Okay, diffuse particles of food coloring into gelatin particles. Easy, mix together. Gelatin particle, food coloring particle, they go into each other. So diffusion. Yeah, easy lah. So if you put the container in the refrigerator and another identical container at room temperature, does the food coloring diffuse at the same rate? Explain your answer. So, okay, diffusion, they depend on temperature. Okay, the faster the hotter somewhere is, the faster the diffusion. Okay, so are they at the same rate? You can say no. Room temperature is faster. Why? Because the higher the temperature, the higher the rate of diffusion. Okay, so this is why you see, cold dishes, you know, when your mom cooks dinner, right? When the dish is hot, that's why Chinese we love hot food. Okay, sorry, okay, that's why Chinese we love hot food, because when the food is hot, they diffuse quickly, so you can smell it in air. But if your food is cold, then what dog do I have? I have two. I have two poodles. Wait, guys. Wait. Okay, sorry. Okay, my these two girls, they're very naughty, and so whenever they hear someone, they will start barking. Ding. No. Hmm. Small, 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 small poodles. Okay, two poodles, two very naughty poodles. Okay, they are like, okay, I adopted them lah, so they are not the best of friends. Okay, sometimes they fight. It's like two sisters that hate each other lah. Yeah, because yesterday they went for grooming, so they went out. So they are a bit excited. They wanna go out again. That's why they are very noisy today. Okay, anyway, so moving on. Let's go to number 5. So this is your balloon. Okay, so you see, why do balloons, they sound cute? Thank you. Okay, so you see balloons okay, when you have a balloon, right? Have you noticed this? After a few days, right? You blow a balloon, the balloon just kind of shrink by itself. Diffusion also lah. Because you see, you have very high air pressure in your balloon. So in between your, okay, this is the balloon, this is rubber, right? So in between the rubber, there are actually tiny holes, very small holes that the gas can go through. Okay, I mean very small. That's why they go through very slowly. That's why after a few days, your balloon just kind of shrinks in size. Diffusion also lah, right? So the balloons were filled with perfume before they were tied closed. Wow, apparently this person is very rich. So inside all the balloons, there are perfumes. So guests who attended the party could smell the fragrance, okay? Because when you have perfume inside, when they diffuse out, okay, when they diffuse out, so you smell the perfume, lor. Right, so how did the fragrance get from inside the balloon to outside the balloon? This is diffusion. Oh, wait. We cannot write diffusion for here because next they'll ask the process. Okay, diffusion is for here. So how did it move? You can say the fragrance particles spread out in the room. Okay, they spread out. Right, so B, when a balloon filled with air was left for a day, it became smaller. Like what I said, what can you infer from this observation? Infer means to explain. Okay, what can you explain? How can I explain this? How can I explain this? So you can say air diffuse from inside balloon to outside. Okay, they diffuse from in to out. Same answer also lah. Okay, same answer over and over again. So C, balloon is placed in a freezer, okay, for an hour. Predict the change in diameter. Okay, so if you blow a balloon, you put it in the freezer, what happens to the balloon? The balloon shrinks, right? This is pressure already, you see? Pressure is banging on the wall. So the lower the temperature, the lower the pressure. Remember here? You see? Lower the temperature, higher pressure, higher temperature. So lower, lower lah. Okay, lower, lower lah. So okay, the change in diameter, it becomes smaller. It becomes smaller. Now, why? Because you can talk about pressure, or you can talk about diffusion. I would accept also. Okay, so the lower the temperature, the lower the air pressure. Okay, or you can say the slower the diffusion. Okay, yeah, both answers work. So I'll go for the pressure one lah, because it's easier to write. So number 6. Okay, let me copy this first. Right, so number 6. Diagram 1 shows 3 glasses containing different liquid. Red color liquid is added into each glass. Okay, so rate of change of liquid color. Guys, you know what? We skip this lah, huh? Because it's the same question over again. It's diffusion again. All right, let's talk about change of phases. Okay, what is PQR? P is melting. Don't get this wrong, guys. It's very embarrassing. So Q is called condensation. This happens to your glasses if you eat noodle. Okay, glasses gang, you understand. It's a very annoying question, a very annoying problem. Okay, I wore glasses since I was 7. Right. So from solid to gas, this is your dry ice. Diffusion slow, balloon becomes slow, smaller, right? Yeah, actually, Felice, I think your answer makes sense, okay? But the pressure become even smaller. So this is a mix. This is a mixed question. Okay, but they still become smaller. They still become smaller. So guys, let me talk about this. You might say, okay, so the slower the diffusion, right? You might say, so isn't slower the diffusion, the balloon becomes not that small. Yes, that is correct. But because the pressure they lower down even faster, so they become smaller. So that's why this question is a bit mixed. Okay, this is a difficult question. Right. So what is dry ice? What is this process of dry ice called? This is called sublimation. Right? Dry ice, they don't turn into liquid. Dry ice is carbon dioxide. They straight away turn into gas. So okay, they straight away turn into gas. So that's called sublimation. So process P involves absorption or releasing of heat. Okay, so if you're scared, sir, the red and blue arrow, right? I cannot differentiate. Very easy one. You just look at the temperature. Process P is what? Process P is melting, right? You see, ice is 0. The water you drink is 30. Okay, so when water becomes hot, they absorb heat lah. I absorb heat, I become hot. Right? And then number 2, the rate of movement of nitrogen dioxide in the air is what than the rate of movement of water in a cup. So this is gas, this is liquid. So which is gas is, of course, faster lah. Gas moves faster than liquid. Okay, so sun is categorized as, okay, what is this? Plasma. This one just learn for fun lah. You don't learn this, but just like, okay, what is plasma? Fire is plasma. Okay, fire is plasma. Fire is not a gas. Okay, fire is also not a liquid, so fire is a plasma. What is a plasma? Plasma is what we call a charged gas. It's the 4th state of particle. You thought particles only got 3 states, right? Only got solid, liquid, gas, right? And then there's plasma, and then there's another one called Newtonian fluid. You know what is this? Newtonian fluid. Yeah, this thing is quite fun, This thing is quite fun. You punch this fluid, right? You punch this fluid, you cannot go through. But if you slowly put your hands into it, you can scoop the liquid out. That is Newtonian fluid. So okay lah, this thing is engineering stuff already. Again, next time you want to go university, you can do all you want. Study this all you want. So change in the vibration of particle during P and R. So P, they become hotter. R also become hotter since when they become hotter. What do? They vibrate faster. Vibrate faster. Okay, because they gain energy. Okay. So natural phenomena which involves P and Q. Where can you see this in nature? P. You can say melting of snow. Okay, melting of snow, melting of glacier. Plasma is a solid and liquid mix. No, it's not solid and liquid. It's charged gas. Okay, gas with charge. Gas with positive, negative. Even in year 10, year 11, you also don't learn this one. This is like university stuff. You know aurora? You know aurora? Aurora is a plasma. Yeah, there. Northern lights. Northern lights. Aurora lah. Okay, if you have the chance, you can go see this. It's usually in the North Pole lah. It's usually in the North Pole. Have you seen this before? I mean, not in real life lah. Maybe in photos lah. This is caused by the sun. Okay, when the sun they explode, you see aurora. Okay, I mean, this is actually a disaster for Earth lah because it's a lot of radiation for us. But hey, it looks cool. Okay, it looks pretty. I see they even dance on. This thing moves you can see them dancing in the sky one. So it's cool, I guess. So melting of snow. So what is Q? This is the formation of rain. Okay, formation of rain. Okay, formation of rain. Right. So next E, water can change from one state to another. Complete the following to show blah blah blah. So solid to liquid, ice to water. This is absorbed heat. I'm just gonna write A here. Sorry, guys, there's a mosquito under my table, and it's really annoying. I'm gonna slap the shit out of this fella if I get the chance. Okay, sorry. So, process. This is called melting. Okay, melting. Liquid to solid. This one reverse so release heat law. So this is freezing. Dipping freezing and then gas to liquid. Okay, gas to liquid is your condensation. Okay, this is your condensation. So condensation is release heat. They become colder. Release steam. Gas is 110 degrees maybe. Liquid is like 90. So you become lower, so they release heat. They become cooler. And they become cooler. So next, F. Student's glass fog up when he eats hot mee soto on a cold day. So you get fog on your glasses. So this is your condensation. Okay, I'm just gonna write con here. So chocolate melts. You see melt here already so melting lor. Okay, melting. And then mother finds that volume of soup decrease. This is your boiling. Because when you cook soup is boiling, right? So they lose water. That's why have you noticed this? When your mom cooks soup, right? The first bowl of soup is very, very, very bland one. Okay, and then when you drink to the bottom, because your mom will boil the soup for like few hours, and then the most bottom one is like the thickest soup you can get because the water is lost lah. So number 4, wet clothes that are exposed to the sun dry after 2 hours. So when you dry your clothes, this is your evaporation. Okay, evaporation. So guys, if you want to lately, right, it's rainy season, right? Okay, you see raining every day now. So if your clothes are very hard to dry, there's no sun, buy clothes dryer lah. Okay, buy clothes dryer. You know what's a clothes dryer? You know what's a dryer? It looks like a washing machine. You put your clothes inside, then it spin. Dry your clothes so that your clothes doesn't smell. So why do clothes smell? Okay, scientific fact. Why do clothes smell when you don't dry them quickly? Because when it's rainy day, you dry your clothes outside. air is very wet. So when your clothes is wet, you will have bacteria growing on it. Guys, all smells, body smell, your body odor, 你的体味啊, your body smell they are all caused by bacteria. So why do you smell here? Why does your armpit smell? Because you have bacteria lah. So when you shower, you kill all the bacteria, no more smell. And then you don't shower, the bacteria grows back, then you are smelly again. Same thing goes to your clothes. So dry your clothes fast, and then you won't get this problem. So next, boiling point of view substance. What is meant by boiling? Melting point. Okay, the temperature at which a substance turn from solid to liquid. Okay, so predict the state of matter of substance W at 100. Okay, W, right? At 100, right? You see, 100 is more than boiling point. So this is definitely a gas. They give a reason because it's above W's boiling point. Okay, you know what is this, guys? You know what boils at 78 degrees? Alcohol. Okay, alcohol. You know your hand sanitizer? Alcohol? Alcohol will boil at 78. That's why alcohol, they dry faster. You see, you wash your hands, your hands are wet, right? You need to wait for like a few minutes for your hands to dry, but alcohol will dry in seconds because their boiling point is much lower. So next, physical change again. So you have your ice here. What is iodine? Okay, iodine is a lot like your dry ice. Okay, they will straight away change to gas, and then when you heat them, they change to gas, right? And then when they touch this ice, they change into this solid again. By the way, this iodine, they look really cool. You see, iodine, when they are solid, they look black. Okay, they are this black color solid. When you heat them, right? When you heat them, okay, let me see if I can find. When you heat them, right, they will turn into this purple gas. There. You see? By the way, this is poisonous. Poisonous. They are the cousin of chlorine. You know chlorine, the thing you put in swimming pool. Chlorine, fluorine, bromine. You know the brown color bromine just now. Bromine, iodine, all the in one. They are all poisonous. Okay, please don't smell this thing. You will die. This is why we use iodine and bromine and chlorine to kill bacteria in water. You put this in water, bacteria will die. Okay, so this is your vapor P. Okay, so what is vapor P? This is purple. Solid L is black. So where is the solid L deposited? Under the wash glass. Under the wash glass, you see, you know, your solid L here. What's the change? What is this process called? This is sublimation. Okay, sublimation. In Mandarin, it's called 升华. 升华, this is your dry ice. You learned this last year. Okay, I'm sure. Maybe you forgot already lah. Okay, so next, name the process. Hey, wait, the answer should be here. Oops. So what's the change? I don't want to write heat, gain heat and lose heat, because this thing they absorb heat, this thing they lose heat though. So there's two here. You write this yourself lah. So heat, there they're asking for the heat change. Yeah, I don't understand what this question wants. So explain the heat change in the above process. Okay, so I just write it up here lah. This part they gain heat. This part they lose heat. You just write it here yourself lah. So number 9, I'm just gonna skip this also, because we did this question just now, right? So guys, yeah, guys, please, all the things. Okay, you guys are in year 9, right? Okay, a word of advice, guys. Advice for you, whatever you learn in year 9, year 7, 8, 9, we call it the lower years. Okay, the lower years. I know there's no final exam. I mean, there's no important exam. But please do not forget whatever you have learned. Okay, these are what we call your basics. If your basics are not strong, if your basic is not strong, your year 10 and year 11, you will suffer. Okay, you will suffer because you'll be learning the same thing again, and you need to go back to this same thing again so that you can understand more difficult concepts. You get what I mean? You get what I mean? 你把你的 basic 忘掉了哦，你现在要学更难的东西就更难了，你就要回来学这个东西学多一次。So I advise you, try not to forget these things. Okay, because if not, your upper years you will be spending a lot of time. Right? Because you have year 11, you have your O levels exam, right? That thing will be, if you're taking Cambridge, then your exams will be sent to Cambridge. So be careful. All right, so number 10, air pressure. So how is, okay, there's a typo here. How is air pressure produced? So you can say like I said, air particles, they bang on the wall. Okay, then you see here already, what? Air particles hit the wall of container. So air particles collide with wall of container. Okay, particles collide with wall of container. So B, then the container is placed at a hot place for 15 minutes. Next, what happens to the air pressure? Of course, it increases. Okay, because when temperature increase, air pressure increase. Because they hit the particles, they hit the wall of container more often. You see, more heating, higher pressure. So hot, move faster, more heating, more pressure. You'll be explaining the same thing in physics next time. Okay, your year 10 physics, you will explain the same thing. Okay, so again, hot, move faster, more banging, more collision, they become hotter. They become higher pressure. Okay, so next, if the volume of the air is reduced, they make this thing smaller. Does it change the pressure? Okay, yes, the pressure increase, because the lower the volume, the higher the pressure. If I make this room smaller, so now the particles will hit the wall more, higher pressure. Okay, more heating, higher pressure. So notice, right? Okay, so next, this is atmospheric pressure. Okay, this is atmospheric pressure question. Like I said, there's more air pressing on this person, so higher atmospheric pressure. Less pressure pressing on this person, so lower atmospheric pressure. This one you know, right? So compare the atmospheric pressure at R and S. So pressure at R is higher than S. High pressure here, low pressure here. That's why when you're up there, right, if the pressure is too low, you cannot breathe properly. Okay, you'll get something called altitude sickness. You will be so out of breath that you feel lightheaded and you feel like vomiting. That is your altitude sickness. So B, based on the principle of air pressure, explain the condition faced by Jasny at location S compared to his location R. So condition, you can say Jasny, like I said just now, Jasny is facing altitude sickness. Okay, he's becoming sick because it's very high. Because Jasny has lower atmospheric pressure than his friend. So you feel very sick. Right? So people who live, you know, high up the mountain, okay, like in Mongolia. Okay, is it Mongolia? I think it's Tibet. Okay, you know those Tibetan monks, Tibet monks, 这种西藏的和尚 they live high up the mountain. So why don't they get altitude sickness? Because they got used to the place there. Okay, they got used to the place there. So if you stay there long enough, your body will produce red blood cells so that you can live there like a normal person. So relationship between altitude and atmospheric pressure, like I said just now, the higher the altitude, the higher you go, the lower the atmospheric pressure. Okay, the lower the atmospheric pressure. Right, so next diagram above shows the same bread taken by Jasny to a high altitude. What happens to the packet of bread when she arrives at high altitude? So what happens here? Right, so this is high altitude when she arrives at high altitude. Right, so you see, when you take, okay, next time you can try this if you're at KL, you see, if you're at KL, right? Let's say this is KL lah. If you're at KL, outside pressure very high. Around us, we have high pressure, right? And then when you go to Genting, okay, you try to put an empty bottle in your car. When you're at KL, before you go to Genting, let's say you guys are going to Genting, you put an empty bottle in your car. Why? Because when you reach Genting, the pressure surrounding will be low, but inside the bottle is still KL pressure. You get what I mean? You get what I mean? So inside is, okay, let's say, I'll give you numbers, you understand. Okay, let's say KL is 100 PA. Okay, PA is pressure lah. Okay, KL is 100 PA. So if you bring an empty bottle from KL, inside the bottle is 100 PA air. So when you bring this to Genting, when you reach Genting, the bottle inside is still 100 PA, but now surrounding around you, because you're at Genting, maybe it's now 70 PA. So you see, outside pressure low, inside pressure high. So now your bottle will be very full. Okay, 很胀, very full. So when you open the cap, okay, you'll hear pop. Okay, that pop sound because the pressure is trying to come out. You try this and see. You try this and see. And then if you do the reverse, after you open this, right? Okay, after you open this, you close it back again. Now inside your bottle is 70 PA. Okay. So what happens now? When you come back down to KL, now KL is 100. Right? Now KL is 100. Now your bottle is 70. So what happens? What happens? This 100 will crush the 70. So now your bottle will look like crumpled. Okay, you try this and see. You guys going Genting anytime soon? You try this. Interesting. You try this. Okay, when you reach up there, the thing will be very full. When you reach down here, the thing will be crushed. Remember to put the cap lah. Don't be silly. You say, hey sir, why doesn't work one? You don't put cap how to work. Please put your cap. Okay, so I mean, you might say, sir, when we go Genting, right? Why don't we get altitude sickness? I mean, Genting is not very high lah. Okay, Genting is not very high. Unless you one shot, you climb up Himalaya or you climb up Mountain Kinabalu, then yes, you get altitude sickness. Okay, because Genting is not very high. Okay, it's still breathable. Okay, anyway, so what happens to the pack when she arrives at high altitude, right? So now, what happens to this bottle when you bring from KL to Genting? So the thing will be full, right? So the packet is tight, okay, or full of air. Okay, it's like inflated. Yes, that's the word. Okay, silly me. That's the word. Okay, the packet is inflated. You can explain why, because surrounding atmospheric pressure is lower than inside the packet. Okay, so surround you, low pressure, they'll try to push out. So now this thing becomes full. Okay, so understand, guys? Can understand, So I think this is the last question. Okay, we finished just in time. Although we have like 3 minutes. So, guys, I think I'm going to stop here. Next week, I hope we can. Okay, we have 2 more weeks. I hope we can finish this. Right. So, since you're nearing year end, right? Okay, I might include some year 10 stuff for you. Just for fun, lah. I mean, you guys are not learning it for exam, but sometimes let you guys read a little bit of fun stuff. Would be better than just you learning some boring syllabus, isn't it? Okay, so I'll see how lah. I will see you again next week. Okay, thanks for coming, guys. We learned something new today. I will see you again next Friday. Have a nice Friday. Have a nice weekend. I will see you again soon. Right? So take care. See you. Bye bye.